Before quantum mechanics, before wave functions, before the mysteries of particles and probabilities, we need a language. That language is mathematics. Today, we begin at the very bottom of that ladder with the idea of a set. Today, we begin at the very bottom of that ladder with the idea of a set. A set is simply a collection of objects. Think of a basket of fruits: apple, banana, orange. That's a set. In math, the objects can be numbers, shapes, or even abstract things. The rules are simple. Either something belongs to the set or it doesn't. Nothing complicated yet. But here's the secret. Sets are the foundation of all higher math. Every structure we'll use in quantum mechanics is built from sets, given more and more rules. Some sets are more powerful than others. For example, the set of natural numbers, 1, 2, 3, 4, lets us count. But what if we need 0, or negative numbers, or fractions, irrational numbers, 2, discovered by Greeks? This journey gave us bigger and richer sets of numbers. And the most important for quantum mechanics are real numbers and complex numbers. And the most important for quantum mechanics are real numbers and complex numbers. Real numbers are everything you can place on a number line. Whole numbers, fractions, decimals, irrationals, they all live here. Quantum mechanics uses real numbers to describe measurable things, like energy or position. But the true magic happens with complex numbers. A complex number has two parts, a real part and an imaginary part, written as a plus bi, where I is the square root of -1. At first glance, this looks like pure fantasy, but in fact, complex numbers are the very heart of quantum mechanics. Now we come to something crucial, the idea of a field. A field isn't just a set of numbers. It's a set of numbers where we can add, subtract, multiply, and divide, except by 0. In other words, it's a playground where all the arithmetic rules we know actually work. The real numbers form a field, the complex numbers form a field. At this point, you might ask, why are we doing all this? Because quantum mechanics is written in the language of linear algebra and analysis. So we've laid the foundation. Sets gave us collections. Fields gave us well-behaved numbers. If you want to go deeper and practice these ideas step by step, we've prepared maths notes for quantum mechanics, designed for beginners, explained simply, but carrying you all the way to advanced concepts. These notes include worked examples, diagrams, and problem sets. Everything you need to master the math of quantum physics.